We have to find the resultant. Here also angles are given with horizontal line. First force is making 30 degrees and next force is making 120 degrees and the third 30 Newton force is making 210 degrees. Okay. We need how to find the resultant force at A point, because at A all forces are acting. Now here I will redraw the diagram. In it I will take all the angles are horizontal as we did previously. Just do the same diagram. Here 10 Newton force, how much it is making? 30 degrees. And next is in the second coordinate, so it is 20 newtons. Now here the angle is, take with horizontal always, as I told previously also. It is with this line, it is 120, but it is in the second cube. Now take the angle with horizontal in the second cube. This angle will take down. So as we know, at this line, if any line, okay, this angle is 180. Okay, so total is 180 minus 120 will give this angle. Okay, so 180 minus 120 means it is 60 degrees. Now I can take this 60 degrees here. So remember, the position of the angle is always, if the force is in the first coordinate, take the angle with horizontal in this line with the horizontal. If the force is in the second cube means, second coordinate means, take the horizontal angle like this. And third force is 30 newtons. Now this is the third force, 30 newtons. It is making total 210 degrees. It is in the third cube, third coordinate. Now we have to take the angle this one. Okay. So how to get 210 minus 180? This angle is 180. So 210 minus 180 is equal to, we'll get this angle is 30 degrees. Okay. So this is the given diagram. What we did means, we are taking the horizontal angles. If it is in the first cube, we are taking this horizontal angle. If it is in the second coordinate, this angle. If it is in the third one means, we have to take this angle. If the force, given force is here means, take this angle. Okay. Always remember, here all forces are inclined. So for that, there are two components for each inclined force. Let us take the example how to find the horizontal component, vertical component. As I mentioned in the previous class, if the force is inclined to some angle, it has two components. One is horizontal component, it is acting along this line, and one vertical component, it is acting along this line. Both x and y values are positive. Now here how to find the cos value and how to find the sin vertical value. Now here yesterday I have explained, make the triangle. Okay, you just make the triangle here. Now this is the horizontal component. Vertical, whatever it is coming, we have to mark here. Okay, FV value, FH value. Okay, this is the first force, that's why FH1, FV1. Now by using this triangle, okay, so this is F1 value, magnitude F1. And we need to find this horizontal values, so we can apply cos 30. In this triangle, cos 30 is equal to FH1 by F1. FH1 by F1. F1 quantity will be given. So we need to find FH1. FH1 is equal to F1 cos 30. Okay, we can find this value by using the given values. Now, next we need to find the vertical component. How to find vertical component? Fy1. Okay, V1. So Fv1 we have to take here in this triangle. How to find the value vertical component? Sin 30 is equal to Fv1 by F1. Fv1 by F1. Now here we need to take Fv1 value is equal to F1 into sin 30. Sin 30. Okay. Now here there are two components for this force. Okay, horizontal, vertical. Now how to do this diagram? By taking these two components. Horizontal component, this is the horizontal component, it is acting in this direction, F1 cos 30, and vertical component is F1 sine 30. Now instead of this diagram we can take these two components. Okay, instead of this inclined force we can take two components. So similarly we have to change this inclined component also into one vertical and one horizontal. Here also one horizontal and one vertical. Like that we have to divide entire diagram in terms of all horizontal components and all vertical components. Okay, this process is called resolution of forces. Means dividing this force, inclined force, into vertical component and horizontal component. So do the resolution of forces diagram. Okay, so in it, what is the first component? 10 cos 30. As I told previously, horizontal component is cos, vertical component is sine. It is in the first cube, that's why x and y are positive and positive. X is in this direction, y is in this direction. 10 cos 30 and sine is 10 sine 30. And next force is 20 newtons. It is in the second coordinate. Horizontal component is negative in this direction. Vertical is upward. Okay, x value is negative, y value is positive. What is the horizontal component? Cos will come 20 cos 60. 20 cos 60. Vertical is positive, 20 sine 60. 20 sine 60. For this force, both horizontal and vertical are negative. 30 cos 30. 30 cos 30. Vertical is downward, 30 sine 30. 30 sine 30. So in it also we have to find resultant force at A point. Because of all this inclined component, we need to find sigma FH value, means sum of all horizontal forces. So for this direction I am taking positive, for this direction I am taking negative. So what are the positive forces? Only one, 10 cos 30. What are the horizontal forces in this direction? 20 cos 60 with minus 30 cos 30. So do we calculate this value. Next value is sigma FV we need to calculate. Now calculate sigma FV. Upward forces I am taking positive, downward forces negative. What are the upward forces? 10 sine 30, 20 sine 60. Downward is 30 sine 30. Here I have written 10 sine 30 plus 20 sine 60 minus 30 sine 30. So the value will be 7.32 newtons. Positive means it is upward. Okay. So this is the vertical component. Now by using calci we got these values. Sigma FH is negative, sigma FE is positive. So where horizontal component is negative and vertical component is positive, in which quadrant? So we can take in the second one. Okay, because we got sigma FH is minus 27.3. Instead of minus I am taking sigma FH value here. How much it is? 27.3 newtons. What is sigma FE value? 7.32. Sigma FE it is. Now resultant is R. So I have calculated sigma FH square plus sigma FE square. It is right angle triangle. Now how much angle it is making means tan inverse of phi is equal to, as we have discussed today, tan phi is equal to this value divided by this value. So phi is equal to tan inverse of 7.32 divided by 27.3. We'll get the angle 15 degrees. Here no need to take this sigma FH is negative here, because already we did the diagram according to the negative sign sigma FH value. So here not necessary to take minus. We'll get 15 degrees. So resultant is making 15 degrees with the horizontal. Resultant is acting in the second coordinate. Okay, according to these two components. So this is the process of finding the resultant. Here we have to write down resolution of forces diagram. So in all diagrams it is very important. So according to this our solution will come correct or wrong. We can decide easily. So in each and every diagram, resolution of forces diagram is very important. In the previous one also we took the resolution of forces diagram here. Horizontal component, vertical components.